you start.
Okay. The testing of hypothesis. Any hypothesis which is being tested is known as a null hypothesis, denoted by H0. And any hypothesis which is not H0 is known as a H1, that will be denoted by H1. The level of significance may be 5%, 1%, and 10%. It may be 1%, it may be 2, it may be 5, it will be given. If it is not given, it is equal to 5%. Then level of significance. The probability of rejecting the net H0 when it is true is known as a type 1 error. And if the rejection region lies on the one side, it will be equal to one-tail test. And if the region of rejection is located on both sides, it will be known as a two-tail test. The procedure of testing the hypothesis is equal to step number 1, make a H0 and H1. Number 2, define the level of significance alpha. It may be 1, 5, and 10%. Step 3, state the test statistics, whether it is a t-test, z-test, chi-square test, f-test. Number 4, find the critical region, the region of rejection on the table. And the last is comparison of calculated value and tabulated value of test statistic. If your calculated value is greater than tabulated value, then reject your H0. Otherwise, accept your H0.
Start.
The proportional test. If you are going to test the proportionality, that is equal to P hat. P hat is equal to X over N. That's a proportion. If you are testing the proportion of a population parameter or the comparison of two population parameters, the test will be known as a proportional test. That's known as a binomial test also. Proportional test also, it will be equal to P1 hat minus P2 hat minus P1 minus P2 over NPQ over 1 over N1 plus 1 over N2 under root. That will be known as a proportional test. And similarly, the procedure of this is equal to just like the P1 is equal to P2 H0 and then H1, then level of significance, then the test statistics, then comparison of critical region, your calculated value. If your calculated value is greater than your tabulated value, then reject your H0, otherwise you accept your H0. Okay, next then.
Start.
Now, testing of hypothesis for one population mean testing. If you are required to test the one population mean, then there will be t-test and z-test. If the sample size is a very large, z-test will be used, and if the sample size is less than 30, t-test will be used. The formula of t is equal to x bar minus mu over s over n and root for t-test, where x bar is the sample mean, mu is equal to the population mean, sigma is equal to standard deviation of population, n is known as the sample size. And if you compare the two means, that H0, if H0 is equal to mu1 is equal to mu2, then t-test will be equal to x1 bar minus x2 bar minus mu1 minus mu2 over sp 1 over n1 plus 1 over n2 under root. But if the sample size is a very large, then it will be equal to z test. Only the difference will be equal to that x1 bar minus x2 bar minus mu1 minus mu2 all divided by sigma sp when 1 over n1 plus 1 over n2, where p sigma p is a pooled standard deviation of two populations. And then the population mean comparison, that's known as the dependent sampling. That's a before treatment and the after treatment. And it is known as, usually it is known as a pair t-test. The formula for a pair t-test will be equal to d bar minus capital D bar over SD into 1 over n. This is the formula for pair t-test, and that's known as a dependent sampling. बस भी खत्म करो. ANOVA stand for analysis of variance. In t-test, usually we test one mean, population mean, or two population mean. But if there are more than two population mean are being tested, then the technique will be ANOVA, that's known as the analysis of variance technique, will be more appropriate. ANOVA stands for analysis of variance, and the ANOVA table is very important, which is given like this. That is equal to first column will be known as a source of variation, the second column will be known as the degree of freedom, third column known as the sum of square, then mean square, then FC, then FT. One by one I explain it. Source of variation, SOV stand for source of variation. DF, degree of freedom, mean the number of independent value minus 1. S stand for sum of square, that is equal to x bar summation x minus x bar square, that is the sum of square. Mean square, this is known as a mean square, MS, and then some mean square, this is mean square, this is FC. So mean square is equal to the sum of square divided by degree of freedom, it will be known as mean square. FC will be equal to S1 square over S2 square, the ratio of two variance, and FT is the value of F from the table. Source of variation due to treatment, due to your between sample or within sample, that will be known as the between sample, and that is equal to within sample, that is equal to degree of freedom. So this is a format of the ANOVA. We will complete it by taking the example next, and this technique will be known as ANOVA analysis, and it is used for testing more than two means of populations. Okay. Experimental design. There are three basic experimental design that will be known as a CRD design, RCBD design, and the latent square design. CRD design means completely randomized design. RCBD design means randomized complete block design, and LS means latent square design. For designing, there are two or three basic principles of any experimental design. The first principle of experimental design is randomization. When each element of the population, or when each unit of the material, or from the each experimental treatment have equal probability to fall in any experimental unit, is known as the randomization. And replication means the repetition of any treatment at least more than one, that will be known as replication. every treatment should be treated, must be repeated more than one. Local control being the controlling of the variable other than treatment will be known as a local control. And then there are three CRD design will be used when experimental material or units are homogeneous. RCB experimental material is used when experimental units are heterogeneous. And the variation if it is on two-way perpendicular to each other, then it will be known as the Latin scale design. बस बड़ा है. There is a test that's known as a test of independence. That's known as the attribute. Attribute is actually that variable which cannot numerically measure. It can be presence or absence of any character, like smoking, like area, like grade. These are also known as attributes. Beauty is attributes. That's known as intelligence as attributes. Education is attributes. Now, if you compare the comparison, if you want to compare the attributes, two attributes are independent or not, whether a mark depends upon gender or not, whether the IQ depends upon the genders or not. There are two attributes, that gender is a one attribute and the IQ is the second attribute. If you want to know the association of this, so that will be, the test will be known as the chi-square. So the procedure is similarly, that the first step is a make H naught. That is, there is no association between two attributes. With H1, there is association between attributes. Second step is a level of significance. It will be given or it will be, if it is not given, it will be equal to 5%. And the third step is calculate the chi-square calculated. That is equal to like this, chi-square C is equal to O minus E square divided by E, then sum it. These are known as the chi-square statistics, where O is observed value and E is expected value. And how it will calculate E value? E is calculated with row sum into column sum, all divided by total number of observation will be expected value of that is equal to E11. It means that first row and first column, the expectation of first row and first column. So we calculate the contingency table mean, the rows, two rows and two column, then will be known as a 2 into 2 contingency table. And if there are 3 into 3 rows, 3 column, there will be 3 into 3 contingency table. So you calculate the chi-square value, statistics value, then take the critical value from the table, chi-square tabulated value, and if your calculated value is greater than your tabulated value, you reject your H naught, otherwise accept your H naught. Agla boli. Between dependent variable and independent variable, that is equal to y is equal to a plus bx. That's known as a simple linear regressions, where y is the dependent variable, x is the independent variable, a is known as the intercept, and b is known as the regression coefficient. Y is the known, x is the known, a is the unknown, b is the unknown, a is the estimated width, and b is estimated like formula summation xy over summation x square, or shortcut formula is equal to summation xy minus summation x into summation y divided by n, all divided by summation x square minus summation x whole square divided by n. And a, the intercept, will be equal to y bar minus bx bar. So So this is the estimation of A and B. That's a regression, simple regression coefficients. The sampling distribution of A is also normal with mean and variance. Where the B, the regression coefficient, is sampling distribution is also normal with some mean and some variance. We may test H naught that B is equal to 0, and with alternative that B is not equal to 0. So, after calculating A and B, if we put the value A and B in the simple regression equation, that is equal to y is equal to A plus bx, so it will be known as a regressed equation. It is known as a estimated equations. The most use of this regression equation is the prediction or the forecast. And this is the case when x and y are, there is only one dependent variable and x is one independent variable. If there are more than one independent variable in the equation, like y is equal to a plus b1 x1 plus b2 x2 plus so on bk xk, it will be known as a multiple linear regressions, where A is known as the regression coefficients and the betas are known as, A is known as the intercept and betas are known as the regression coefficients. Then R square. R square is known as the coefficient of determinations. That is equal to, the formula for this is equal to summation y hat minus y bar square all divided by summation y minus y bar square. It is a variability in y, independent variable due to independent variables. That's known as a R square. And 1 minus R square is known as a due to error. How much variability occurred in the data due to other than independent variables. And then correlation. There is a slight difference between regression and correlation. In regression, the dependent variable and independent variable is clear. As you can differentiate, this is a dependent variable and this is a independent variable. But if you cannot differentiate dependent and independent variable, only the relationship will be measured between two variables. It is known as correlation. The simple correlation coefficient or simple correlation means the correlation between two variables. That's known as simple correlation. And how the relationship is measured? The relationship is measured by the correlation coefficient. That's denoted by small r is equal to summation xy minus summation x summation y over n all divided by summation x square minus summation x whole square divided by n under root multiplicate the summation y square minus summation y whole square divided by n under root. That will be known as the correlation coefficient. Its range will be equal to -1, 2, plus 1, then 0. If correlation coefficient is equal to 0, there is no correlation between two variables. Both the variables are independent. And if the correlation coefficient is a plus side, it will be equal to positive correlation. If it is equal to minus sign, it will be called as negative correlations. And if it is near to 0, it means there is no correlations. And this is known as a simple correlation coefficient. But if the correlation between more than two variables, it is known as a multiple correlation or partial correlation. So the multiple correlation or partial correlation, the example will be given at the end. Okay.